Here. In this video, we are going to see about the 8 quints problem. I am Karthikeyan, Assistant Professor, Department of Computer Science Engineering, Hindustan College of Engineering and Technology. First of all, we have to see about what is 8 quint problem. In this 8 quint puzzle, the problem is placing our 8 chess queens in a board, and that there is no two queens attacked with each other. Thus, a solution required for there is no two queens are the same row or same column or a same diagonal. With this these 8 queens puzzle, this is example of the more general n queens problem of placing a n queens on a n chessboard where solution to be existed in the natural numbers such as 1, 2, 3 up to n. The solution is possible or discovered by the only up to 23 coins has to be an up to now has to be an founded. So the first inventor of this problem solution by the Max Basil. This is originally proposed in 1848. With that, many mathematicians, including Gauss, has to work on the puzzle and has generalized the n queens problem with the help of Max Basil. The first solution of 8 queens were provided by Franz Knock in 1850. Knock also extended the puzzle to n queens problem on a n board chessboard of arbitrary size. In 1874, Ginter has proposed the new method of finding the solution by determinations, and J.W. Gleiser refined this approach. And then another Edgar Dijkstra used the problem in 1972, which is a Dijkstra algorithm to illustrate the power of structured programming. And then next is finally he published the depth first backtracking algorithm. This is the up to now solution for the 8 queens problem. This is a arc diagram for the 8 queens problem. Here there is no movement of our queens in each row, each column and each diagonal faces. With this formation, we have to get the formulation. With that, first state it is any arrangement of 0 to 8 queens on the board. We can have to arrange the board, and then initial state 0 queens on the board. This is the initial state, and then next is add a queen in any square. With that, it will not be occurred with the same row, same column and same diagonal. With the goal test 8 queens on the board, none has to be an attack with each other. Then first algorithm invented for the 8 queens problem is a navy algorithm. With this, it will place the queens in the dotted line. With that, it will be having a repeated process. Try to place the rest of the queens in other dotted places and then unplace the queen. With this having a, we have to infinitive calculation like that 64 into 63 into 62 like that the whole chessboard has uh, corner has to be calculated and has to be found a solution. It will be a very huge process. And then next algorithm they will found it as a better algorithm. With this, in a working of solution, exactly one queen must appear in a one row. This also to be a redefined process, and then valid permanent in a queen. If it is any other queen appeared in the same column, we have to move on to next thing. So this will be calculated it as a 8 into 8 into 8. And then next apart from that, next algorithm is a backtracking concepts has to be used to still now. Each recursive call attempts to place the queen in a specific column. The previous algorithm what we have done, we have to done it the same here. For a given cell, the state of on the previous placements is known. We have to change the column. Okay. First thing, there is a two steps of backtracking concepts: current step backtracking and previous step backtracking. Current step backtracking placement within the column does not lead to the solution. Then queen has to remove and then move down to the next column. Then previous backtracking, when all the rows in a column have been tried, then we will call the termination process. That's the end of the our situation algorithm. And then next concept is a pruning. If a queen cannot be placed into the column, then do not try to place on onto the column I plus 1. Okay, this is another one rule, that is a pruning rule. Then backtrack to column I minus 1 and move to the queen that had been placed there. So that empty column must be filled. Using this approach, we can reduce the number of potential solution even more to the another algorithms. This will be a 4 queen problem. This also to be a another problem. We have to having a 4 queens, and then we have to give the solution, place the queens without attacking each other, and then we have to steps revisited in the backtracking for 4 queens problem. With this plus first place the first queen in the left upper corner of the table, and then save the attacked position. Okay, and then third point, move the next queen, search for the valid position where we have to place. There is not a valid position for the queen, delete it or coordinate it as a 0. Move the previous queen, go to step 4 until we have to place the all the queen. Places to the first valid position, and then save the attacked position. If queen is processed in the last step, otherwise it will go to the step 3, and then again we have to loop the process. This is some example coding for 8 queens problem. Here we have to using the position. If it is less than a row is less than 8, then we have to next row we have to move it. Otherwise we have to give it as a success process, and then remove the queens from the position. And then we have to check the another looping concept. We have to check the diagonal also. This is another coding. We have to check the diagonal process with the rows and the column. And then we have to give the solution for 8 queen as a we have 92 distinct solution for the this 8 queens problem apart from the backtracking. If solutions that differ only by the symmetric operations, notations, sorry, rotations and reflections, but it will be having a only 12 unique solutions has to be an approved. This another one is a SOMER'S algorithm. This algorithm supportable for the n-queen problem. And then this is the fastest algorithm for supporting the n-queens. And then it will be founded by the Xiaoluan Pian and Joel N. Force. Okay, this algorithm also based on the backtracking algorithm. Maximum time taken to find all solution 8 queens problem. Yeah, at the timing is 19 minutes 26 seconds. Whereas in normal backtracking algorithm, it will take the 75 minutes. Why we are needed of our needed of our backtracking in a nested loop. With this loops are not repeatable process only. We have to identify the record rows and the column. The major advantages of our backtracking algorithm is ability to find a minimal count and find the solution. If we go through algorithm, we have to find it in 981 queens in 8 queens problem, record for first solution alone, and then we have to get the 92 solution for 16,704 moves. That's all about our 8 queens problem. Thank you.